In this video, I will go over your pre-calculus Unit 4 review, and this is the calculator portion. So since we're doing trig in calculators, we have to be deliberate about whether we're in radian mode or in degree mode. So for the application questions, which is we're starting this, you want to be in radian mode. So our first problem, in predator-prey situations, the number of animals in each category tends to vary periodically. A certain region has cheetahs as predators and antelope as prey. The number of cheetahs varies with the time according to the function, okay, and the antelope is this one. So what are the maximum and minimum number of cheetahs? Well, we're going to look at our cheetah equation. We have a midline of 200 and a amplitude of 25. So we're going to have 200, and then we're going 25 above that and 25 below that. Which means our maximum is going to be 225, and our minimum will be 175. The maximum and minimum number of antelope, same thing. We have a midline of 1,250, and we're going 200 above that and 200 below that. So our maximum is 1,450, and our minimum is 1,050. So when does the maximum number of antelope occur? We can do this algebraically, or we can do this on the calculator. So if I'm doing this in the calculator, again, we want to be in radian mode, and then I type in my equation. For my window, I'm going to go from like 0 to 10. We'll see if we need to extend that, because that's our time. On the y-axis is the animals. So we're looking for the maximum number of antelope, which we said was 1,400. So I'm going to go from like 0 to maybe 1,500, because that's above our maximum. All right, so we're looking for this right here. So I'm going to do calculate the maximum. And then it's going to ask for left bound, right bound, and guess. So we go somewhere to the left of our max, somewhere to the right of our maximum, and then our guess. So to the nearest tenth, that's going to be 3.9. And that would be in years. All right, describe the relationship between frequency and period. Frequency and periods are reciprocals of each other. So frequency is 1 over the period, period is 1 over frequency, because period is the time per cycles, and frequency is cycles per time. The Colossus Ferris wheel has a diameter of 160 feet. Riders reach a maximum height of 180 feet above the ground. The wheel makes 1.5 rotations per minute. We're going to sketch the graph and find the equation that models the rider's distance off the ground after t seconds. So let's do the graph first. Okay, so this is going to be time, and this is going to be our height. We know we have a maximum of 180. The diameter is 160. So that means my minimum is going to be at 20. We'll figure out how long this takes in a second. But we start at 20, we go up to 180, and then back down. Okay, so let's determine this. The 1.5 rotations per minute, okay, is going to be a frequency. So the period is going to be 1 over that. And we'll go ahead and this is 1.5 rotations in 60 seconds. We want to turn this into seconds. So my period is going to be 60 seconds for 1.5 rotations. So if we do this division, we get 40 seconds her rotation. That's our period. So this is 40. And then we're going to write our equation. So since we're starting at the minimum, we're going to have a negative cosine, because that starts at the minimum. My amplitude is going to be the distance from the midline here or here. So if this is 160, the amplitude is going to be 80. Our period we just established was 40, which means my b is 2 pi over 40, or pi over 20. My phase shift is nothing, since we did a cosine. Our vertical shift is this right here. So I can add these two up and divide by 2, or I can take the amplitude and add it. Either way, we're going to get 100 for that. Okay, so putting this all together in the equation, my height is going to be negative 80 cosine. My b was pi over 20. T, we don't have a phase shift, but we do have a vertical shift. A piano tuner strikes a tuning fork for the note A, which has a frequency of 440 hertz. The sound wave has an amplitude of 2. We're going to write the equation of sine that would model the situation in graph 1 cycle. All right, so my amplitude is 2. The period is going to be 1 over the frequency, so 1 over 440. My b is going to be 2 pi over 1 over 440, which is going to be 880 pi. So my equation is going to be y equals 2 sine 880 pi, we'll just say t for this. For my graph, my amplitude is 2, my period is 1 over 440, and then we will graph. Sine wave. The next one, the average monthly temperature for the city of Seattle is given below. So you can either do a sine regression in your calculator, or we can just do this using the information we have. So our graph is going to start at 1, which means the following January is going to be 13. Our minimum temperature is 41. My maximum temperature is 66. So my graph is going to go from here up, back down to cold. So we're going to have a negative cosine again. My amplitude, okay, I'm going to take 66 minus 41 and divide that by 2 to get that distance. That gives me 12.5. The period is going to be 12. My phase shift is going to be 1, because we're shifting this to the right one. And my vertical shift, if I take 12.5 and add it to 41, we get 53.5. Or you can do the average of these two, add them up and divide by 2. All right, so if my period is 12, b is 2 pi over 12, which is pi over 6. A phase shift of 1 equals negative c over pi over 6. So my c is negative pi over 6 when I solve that equation. So we're going to have y equals negative 12.5 cosine pi over 6t minus pi over 6 plus 53.5. Okay, now we get to the triangle portion where you want to be in degree mode. So I'm going to go to my mode, go to degree. Okay, we're going to solve each triangle. So my first suggestion is to draw it, so we know whether we're going to use loss signs or cosines. A is 58, B is 57, B is 12. Okay, so this is angle, angle, side. So this is going to be law of sines. When solving, we want our angles and our sides. We already know those. We subtract from 180, and we'll get 65 for the third angle here. To find A and C, we're going to have to use the law of sines. So we have our known angle and side. Okay, so when we cross multiply, we'll multiply this and divide. So we're going to have 12 sine 58 divided by sine 57. And you'll type that in the calculator. You get 12.1, and then we'll repeat that for C. So sine 57 over 12 equals sine 65 over C. So C is going to be 12 sine 65 over sine 57, which is going to be 13.0. All right, and our next one, triangle EFG, we have a side F is 37, side E is 34, and angle F is 22. So this is again going to be the law of sines, but this is angle, side, side. Okay, which means this is the ambiguous case. So we have to check for if there is 0 triangles, 1 triangle, or 2. So we start with the law of sines. Sine 22 over 37 equals sine of E over 34. Okay, cross multiply, divide by 37, and then we're going to take the sine inverse. So E is the sine inverse of all of that. Okay, which gives us 20.1. Okay, so we know that there's at least one solution. What we need to check is if there's a second. So we call that the obtuse possibility. Because if there's a second, it's going to be the first one that we found's supplement. So I'm going to take 180 minus 20.1, which gives me 159.9. If I add 159.9 and 22, we get a number that is bigger than 180. So there's only one triangle. Okay, so we found E is 20.1. If I subtract from 180, G is going to be 137.9. Then we just have to find the last side using the law of sines. So when we cross multiply and solve, okay, we get that. And in the calculator, which is in degree mode, we get 66.2. All right, the next one, side F is 18, side G is 12, and 80. This is, again, the ambiguous case. So we'll set up the law of sines. Okay, when we solve all the way down for F, it's going to be the sine inverse of 18 sine 80 over 12. Okay, if we type that into the calculator, we get an error. Which means there is no triangle. Okay, next one, another ambiguous case. So So we'll start with sine 42 over 14 equals sine of f over 19. Okay, so we get a value here of 65.2. So we have at least one triangle, because if I had those, we're good. So my obtuse possibility is going to be 180 minus 65.2, which is 114.8. Okay, if I add 114.8 and the given triangle, or given angle, we get a number that is less than 180, which means we have two triangles. All right, so we established there's two, which means we need to solve for both the acute triangle and the obtuse triangle. The given information is the same for both. So G is 42, G is 14, F is 19. Okay, and we found the acute angle F and the obtuse. So this is F1, this is F2. Okay, so we just need to find the third angle and third side here, third angle and third side here. Third angle here, when we subtract from 180, is going to be 72.8, and then I'll do the law of sines to find that. Okay, when we do all of that, E1 is going to be 14 sine 72.8 over sine 42, which gives us 20. And then we'll do the same thing down here. So we subtract from 180 to get this one, which is 23.2, and then do one more law of sines. So E2 is going to be 14 sine 114.8 over the sine of 42, which gives us 8.2. All right, our next one, we have B is 3, C is 8, and angle A is 50. So this is going to be the law of cosines. We have side angle side. So we're going to solve for the missing side. So a squared is going to equal 3 squared plus 8 squared minus 2, 3, 8 cosine 50. We get this value and take the square root, and we get 6.5. Okay, now we get to solve for the angle. We're going to use the law of sines to do so, so we have to be real careful, because the law of sines will only give us an acute angle. So we're going to leave this one for last, since this is the biggest side. This one could be obtuse. So we'll do sine 50 over 6.5 equals sine B, which we know has to be acute, over 3. So B is going to be the sine inverse of 3 sine 50 over 6.5, which gives me 20.7. Okay, so when we solve for our last one by subtracting from 180, we do in fact get an obtuse angle, 109.3. So had I done that one second, we would not have gotten the right answer. Okay, so now we're going to solve this triangle where we have all three sides. So A is 11, B is 20, C is 13. So we need to find all three angles. I'm always going to leave my biggest one for last to make sure that I don't accidentally get the wrong answer. A good way to check is when you're done, make sure that that's the biggest angle, that's the smallest angle, and so on. All right, so I'm going to start with A. So if I'm using law of cosines to solve for A, 11 squared is going to equal 20 squared plus 13 squared minus 2 times 20 times 13 cosine A. When I solve, 11 squared minus 20 squared minus 13 squared. Okay, then we're going to divide. Okay, and then the last step is to do the cosine inverse of all of that. Okay, so when we do that, you get 30.5. Then we're going to do the law of cosines to find C, because we know that one has to be acute. Do sine 30.5 over 11 equals sine of C over 13. When I cross multiply and solve, C is going to be the sine inverse of 13 sine 30.5 over 11, which gives us an angle of 36.9. So again, B does end up being an obtuse angle, so it's a good thing we left it for last. All right, the last two problems, we're going to find the area. So this one is SAS, which means we're going to use 1/2 AB sine C. This one is side, 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 so we're going to use the square root of S minus A, S minus B, S minus C. Aaron's formula. So this one is going to be 1/2 the two sides, 7 and 8, sine the angle in between them, which gives us 13.6, and this will be feet squared. This one, my S is 1/2 of 10 plus 12 plus 15, which is 18.5. So my area is going to be 18.5, 18.5 minus 10, 18.5 minus 12, 18.5 minus 15, which gives us 59.8, whatever units squared. So that's going to be the calculator portion of your test.